Hello aspirants. The last topic that we have discussed is the origin and evolution of the earth. Now in continuation with the origin and evolution of the earth, the topic that we shall be discussing now is the latitudes and longitudes and the positions of the earth. As you all know, in the theme wise series, when you are reading the origin and evolution of the earth, the chapters that you are supposed to read is go to class 6 and class 11. In the class 6, read chapter number 1, chapter number 2 and chapter number 3. Now chapter number 1, 2 and 3, it talks about the earth in the solar system, the latitudes and longitudes as well as the motions of the earth. Now to understand these concepts, you also need to have an understanding about the origin and evolution of the earth, that how did the formation of the earth took place. In yesterday's class, I have explained you in a detailed manner that how the formation of the earth took place, the Big Bang theory and so. So today we will continue with this. In this particular topic, the topic that we are going to discuss is the latitudes, longitudes and the motions of the earth. Right? I hope everyone know what is a latitude, what is a longitude, and before that, to understand them in a detailed manner, you first need to have some basics. Now these basics are none other than the shape of the earth. Now what is the shape of the earth? Yes, in the last topic I have told you that the shape of the earth is geoid in nature. Now what is a geoid? See, our earth's shape is geoid. Now what do you mean by geoid? It is not a sphere. Geoid means at the North Pole and the South Pole, you have a flat top. Okay, near to the poles, you have a flat top, and at the center of the earth, that is near to the equator, you have little burst. And our shape of the earth is like this. It is not a sphere. This is the real shape of the earth. In this real shape of the earth, you will get to know that from the center of the earth, if you start to move towards the North Pole and South Pole, the distance from the center to the north and south is less as compared to the east. That is, imagine this is the east and this is the west and this is at the equator. The distance, imagine this is point A, the distance from point A to the North Pole is less as compared to the distance from point A to the point E. That means the length of the earth or the circumference of the earth at the equator is more as compared to the circumference of the earth from North Pole to the South Pole. Now this is the shape of the earth. You first need to know what exactly is the shape of the earth. For that, let me quickly give a reading onto the literature here. It says that the shape of the earth is geoid. Some sources mention as oblate or spheroid. Now that is, the earth is slightly flattened at the poles and bulged at the equatorial region. Yes, the earth's equatorial diameter is about 12,756 kilometers, is very slightly larger than that of the polar diameter. That means, see, if you look into this earth, the diameter, imagine you take this earth, the diameter from North Pole to South Pole is less as compared to the diameter of the equator. Right? Now, why am I telling all of these things? Because you will be learning about the latitudes and longitudes concept and the calculations of the time, right? For that, shape of the earth is very, very important, right? Now, the radius of the earth is larger at the equator as compared to the radius from north to south pole. This is the fundamental fact. And this is the shape of the earth, right? Clear? That means from equator to equator, it is 12,756 kilometers. From north to south pole, it is 12,714 kilometers. Now that means there is a near about 40 odd kilometers variation is there, right? This is called as geoidal bulge. Now because of this geoidal bulge, the fundamental difference that you get to see is with respect to gravity. Now let's imagine that there is a person who is present near to the polar region and another person who is standing near to the equator. Let's see, this is your earth. Imagine on this earth, you have a person who is standing near to the equator and another person who is standing near to the polar region. Let's call this as Ram. Ram is standing near to the equator and there is another person, Sham, he is standing near to the equator. Now you tell me, who is going to experience more gravity? Easy. Is the Ram going to experience more gravity or Sham going to experience more gravity? Yes, Now take a couple of seconds, pause and try to answer this. Who is going to experience more gravity? See, as you know that the gravity of the earth is origined from the center of the earth. Okay? The gravity concept comes from the center of the earth. This we will get to know in the further classes. So don't worry. Now, whosoever is near to the center of the earth, they will experience more gravity. Now you know that the point, imagine this is point A and this is North Pole. From point A to North Pole, the distance is less, and point A to the equatorial region, bulge, this is more. So that's why you will see that Sham experiencing more gravity because he is near to the center of the earth, whereas Ram, he is little far away from the center of the earth, so that's why they experience less gravity. So you go and look into the people near to the equator, they experience less gravity, and that's why if you wanted to launch a rocket, now would you be choosing a point which is near to the polar region or which is near to the equatorial region? It is always you will like to choose a point near to the equator because at the equator the gravity is less, and your aeroplane or even your rockets, they take less fuel to fly because they have less gravity. But a same aeroplane or a same flight or a same rocket, they take more amount of energy, more fuel to move away from the equator, right? So most of the space agencies and all, they have a launching stations near to this equatorial line itself, right? Okay, now this is a basic fundamental fact, and in the last topic also we have learned that our earth is not a straight line, our axis is tilted by 23.5 degrees, right? Earth's axis is tilted by 23.5 degrees. Now come back to some of the basic concepts, that is earth rotation. See, earth always rotates from west to east. Look here, try to understand this concept. Earth always rotates from west to east. Earth rotates in this direction, and earth will not change the rotation of its direction. It is west, it is east. Earth always rotates from west to east, right? This is the rotational direction of the earth. Now if I am seeing the same earth from the North Pole, this is your North Pole, right? So let me add the grid lines here, you will get a better clarity. Okay, so let's imagine, we are going to the North Pole and earth rotates from west to east. So you see and tell me, you're watching from the North Pole, how is the rotation of the earth? Is it clockwise or anti-clockwise? See, earth always rotates from west to east. Now you are watching it from the North Pole, so earth rotates from west to east, and this rotation seems to be in clockwise or anti-clockwise. So this is how your clock rotates, right? This is called as clockwise. Now opposite to the clock, if the rotation is like this, this is called as anti-clockwise. So now you look and tell me, how is the rotation of the earth? Is it clockwise or anti-clockwise? See, when you are looking from the North Pole, the earth rotates in anti-clockwise, right? And earth rotates from west to east. These are the two fundamental aspects that you need to know, right? Now let's try to understand little more further the concept of latitudes and longitudes. Now the latitudes and longitudes are always studied under a subtopic by the name geographic grid. See, what is this geographic grid? We have divided the entire earth into small grids. Now what is a grid? A grid is nothing but a small square. So like this, our earth is divided into small squares and small rectangles. Now these rectangles, you don't find any lines on the surface of the earth, but these are imaginary lines. Now these imaginary lines are drawn for the understanding, for making our life little more easier, right? So our entire earth is divided into horizontal lines and vertical lines. These horizontal lines, which are circular in nature, we call them as equator. Okay, look at this earth. Now the concept of latitude and longitude came in the year 1500s or so. That is when we decided that we should have some numbering system on the earth, so that if we are moving from one place to another place, we'll use that numbering system and then we'll calculate our time wherever required, our distance wherever required, right? So longitudes help in calculating the time, and latitudes and longitudes together help in calculating the distance and the from one point to another point. Look here. What is the latitude? See, latitude is a line or it's a circle, an imaginary circle that is drawn on the earth. But how are these longitudes and latitudes drawn? See, they are drawn like this. Look at this latitude. Let's try to read the literature first and then we'll try to understand it further. See, latitude is the angular distance of a place north or south of the equator measured in degrees from the center of the earth. The average distance between two consecutive latitudes is taken as 111 kilometers. I know a little difficult to understand. Latitude is an angular distance which is measured north and south. So what is this measurement of angular distance from the north and the south? How did we start to draw these latitudes? Let me explain you. See, you go to the center of the earth. Okay? Let's imagine that you have been to the center of the earth. Now for that, let me show you a small video which will give you a better understanding and a deeper clarity on this. Look here. I want you to watch this video. Right? Look here. See, this is called as the equatorial plane of the earth. Okay, that is called as the equatorial plane of the earth. You have seen here. This is equatorial plane. Right? Now come back. Try to watch this. Latitudes and longitudes are always drawn from the center of the earth. You go to the center of the earth. From there, you start measuring the degrees north and south. Let's go to the center of the earth. Now from the center of the earth, I wanted to point various places. Okay, I am going to point these places. Let me point. This is one point. This is second point, third, fourth, fifth, sixth, like that. This is north. I have drawn a central line. I'll call this as equator, 0 degrees. Now, what I have done is I am pointing few points. Likewise, on the southern side also, I am pointing few points. Now, I'll measure the degrees. Degree from where? I'll measure the degrees from the center of the earth. From here, if this is equator, this is 0. What is this degree? What is the degree? Okay? Like this, I'm measuring various degrees. Now, suppose, let's see, this is 23.5 degrees. That means this becomes 23.5 degrees. Now, look at this. This particular line will become 23.5 degrees north. Right? Likewise, each of this degree is calculated to be the latitude of that particular place. In simple terms, let me try to explain you in little more detail. Suppose this is an angle. Okay? This angle will be called as that particular latitude. Right? Now I am measuring this particular angle. See here. This angle is now 36, right? This is 36 degrees angle. This particular place. That means this point. And here, this entire circle will be called as 36 degrees latitude. Likewise, let me measure this particular angle. If it is 45, then this particular circle will be 45 degrees latitude. Right? Now, latitudes are measured north and south of the equator. Okay? If this is your equator, north of this is northern hemisphere and south of this latitude is called as southern hemisphere. Now, all these latitudes are parallel to each other. They don't meet with each other. Latitudes are circles which are drawn. They are all circles which go around. Now, as you are going from equator towards the poles, the circle size will decrease. The circumference of the latitudes will decrease. So, like this, your latitudes are drawn. Now, very interesting aspect with respect to latitude is that they are known as parallels. Okay? Latitudes are known as parallels because if this is 0 degrees latitude is called as equator, 23.5 degrees latitude, you'll call this as Tropic of Cancer. 66.5 degrees north latitude, you'll call this as Arctic Circle. Likewise, in the southern hemisphere also, you have different names. 23.5 degrees south latitude, you will call it as Tropic of Capricorn. Likewise, 66.5 degrees south latitude, you will call it as Antarctic Circle, right? But there are some fundamental facts that you need to know. Number one, they are parallel lines to each other. Yes, no latitudes will meet. They are all parallel, but all the longitudes will come and meet at the North Pole. Second one, they always run in the east-west direction. They are in the same direction, right? Measures distance north or south. Yes, see, latitudes help in measuring the distance north or south. For example, this is equator. If you ask me what is the distance of this place, so I'll calculate the angle, and you know that the distance between each latitude is 111 degrees, 111 kilometers. So they help in calculating like this. The most important latitudes are, these are the most important latitudes. Now what are they? The most important latitudes are none other than Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle, and Equator. Now a small homework for you. You look into the atlas and let me know what are the countries which are passing through the equator. Equator passes through how many countries? Likewise, you let me know Tropic of Cancer passes through how many states in India. Tropic of Cancer passes through how many states in India? You can look into any of the atlas, right? Okay, that means here I am going to give you the important latitudes as, if this is your Earth, 0 degrees latitude, which divides the Earth into northern hemisphere and southern hemisphere, we call this as equator, right? And 23.5 degrees north, this is called as Tropic of Cancer. 66.5 degrees north, this is called as Arctic Circle. And 90 degrees north, this is called as North Pole, right? These are the most important latitudes in the northern hemisphere. Whereas in the southern hemisphere, 23.5 degrees south is called as Tropic of Capricorn. And 66.5 degrees, this is called as Antarctic Circle. And 90 degrees south is called as South Pole. I hope this is very easy for you. There's not much of difficulty in understanding these concepts. Now equator is the line which is considered to be the biggest circumference of circle which divides the earth into two equal halves, right? Yahan tak clear hai? Any doubts? I hope you are clear with this. Okay, now let's come to understand the concepts of longitude. See, longitude is little complicated as compared to latitudes. Now, why did we draw longitudes? Where did we draw longitudes? See, longitudes alone, latitudes will not help us to understand the movements, the distance. So we have also taken the longitudes. But what exactly is a longitude? Longitude is a semicircle, whereas latitude is a circle. It was a complete circle around the earth. Longitude is a semicircle. Now, longitude is an angular distance of a place east or west of the prime meridian. See, angular distance which is measured from east or west of the prime meridian. Now, what is this prime meridian? See, prime meridian is also called as the Greenwich meridian, which is passing through the line of, this is the prime meridian which passes through the Astronomical Union, which is located in the London, and from this building it exactly cuts this particular place, right? And from here the line was drawn. And look at this. See, from the, imagine this is North Pole and this is South Pole. What we have done is we have drawn a line, imaginary line. This is not drawn on the surface, it's an imaginary line we have drawn, and we said that chalo, this line will act as the prime meridian, the first meridian, right? Like this, what they have done is they have drawn 180 longitudes on the eastern side, 180 longitudes on the western side. As you all know, this is the eastern side and this is the western side. Likewise, lines which are joining the North Pole and the South Pole, which are semicircles, they are semicircles, not full circles, right? Like that, different longitudes have been drawn, and these longitudes are made to come and meet the South Pole, right? So this one semicircle will be called as one longitude. Likewise, on the other side also you have 180 and 180 longitudes. But the only difference is that those longitudes which are present east of the prime meridian, suppose this is prime meridian, and it is called, this part of the region is called as east and this part of the region is called as west, right? Those places which are east of the prime meridian, they are called as eastern longitudes, or those longitudes which are present west of the prime meridian, they are called as western longitudes. Like that, 180 degrees longitudes are there, like 1 degree longitude, 2 degree longitude, 3 degree longitude west, 10 degrees longitude west, 15 degrees longitude west. Like that, you have 100 degrees, 180 till 180 you have western longitudes, and likewise 5, 10, 15, 20 east, 30 east, 40 east, 50 east, 60 east. This is how. But look at latitudes. Latitudes, you are talking about north and south, right? Latitudes do not talk about eastern latitudes, western latitudes. Latitudes say that 23.5 degrees north, 23.5 degrees south. That means latitudes help us calculate the distance from north to north-south. Longitudes help us in calculating east-west, right? Now, how is this longitude drawn? See, longitudes are drawn simple. They are as simple like the latitudes are drawn. Simply, from here, if you see, what is the angle made? Whatever is the angle made, they call this as 10 degrees. If suppose this is 10 degrees, they call this as 10 degree longitude. Suppose like this, there are different lines that are drawn. Now each line will have its own degree, and that is degree is called as longitude. But why are only 360 longitudes are drawn? Why is that the 360 longitudes are drawn? Because there is a strong relationship between longitudes and time. Look here, look at this earth. If suppose, if I am going towards the North Pole, can you see these small lines? All these are lines. Multiple lines are there. Now each of this is a longitude. Okay? So this is the prime meridian, right? I hope now you are able to understand. Okay? Okay. See here. As you all know that Earth is more or less a circle. How much time the Earth takes to go around itself, one full rotation, how much time does the Earth takes? The Earth takes 24 hours to go one full rotation. That means if imagine I am the Earth and I am making one full circle. Okay? How many degrees did I rotate? How many degrees did I rotate? Yes, you can tell me how many degrees did I rotate? See, I have rotated 360 degrees. Right? In how much time? In 24 hours. Earth takes 24 hours to go around itself. Earth takes 24 hours to rotate. And this takes how much time? 24 hours. And how many degrees that the Earth rotate? Earth takes 24 hours to make 360 degrees. Right? Similarly, what we have done is, we called 0 degrees longitude, we said 180 degrees west, and 180 longitudes are drawn on the east. So 180 and 180 is also equal to 360. The main purpose of we drawing 360 longitudes, which are divided as 180, 0 se lekar 180 west and 0 to 180 east, is because we wanted to calculate time. So for that, first let me quickly give out a reading on the literature, the relationship between longitude and time. See, since the Earth makes one complete rotation of 360 degrees in one day or 24 hours, it passes through 15 degrees in 1 hour. the earth rotates from west to east, so every 15 degrees we go eastwards. I know this is little complicated, but I'll make it little more easier for you. See, look at this earth. Where is prime meridian located? The prime meridian, if you can see this yellow line, this is called as prime meridian. The prime meridian passes through from north pole to south pole. This is a semicircle because the earth is bulged. Now this passes through London. They said, chalo, let us draw longitudes east of London and west of London, and we'll name them differently. Like that, multiple longitudes are drawn. Okay, like this. So exactly on the opposite side, I'm talking about the opposite side of this prime meridian, you will also have a longitude. Do you agree? Do you agree that exactly on the opposite side of if this is 0 degrees, this is 0 degrees longitude, on the opposite side of the earth also you have a longitude, and this is called as 180 degrees longitude, right? So if imagine my frontal side of the face is 0 degrees, and what will be opposite side of mine? It is 180 degrees, right? It is 180 degrees. So similarly, earth's opposite side is 180 degrees. Now all these longitudes, what did we call? We call them as eastern longitudes, and all these longitudes which are going from the other side, these are called as western longitudes. Now here 10 degrees west, 20 degrees west, 30 degrees west, 40 west, like that 180 west is present here. Like that 10 degrees east, 20 degrees east, 30, 40, 50, 60, 70, 80, like that 180 east will be there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that every number will have its own longitude. Now we wanted to link these longitudes to your time and calculate the date as well. So we tried hard and we worked it out, and finally we are succeeded. Now look here, our earth is round, but what if I open the earth and make it into a sheet? See, our earth is circular, but if I am going to open up, I'll convert this circle, I'll tear apart the earth and I'll make it into a square. So when I'm making into a square, your earth will look like this. Okay? Do you agree? This is how we draw the map, that circular map we are converting into 180, right? So now see here, if suppose this is your prime meridian, right? Look here, your prime meridian is this. This is your prime meridian. What is the angle? 0 degrees, right? Now likewise, each of this longitude which is there till here 180 degrees east we call, right? Likewise on the opposite side you have, likewise if we go backward, you have 180 degree west, or else can I say this is 179 west and 179 east? Can I also call this as like this, 179 west and 179 east? Now earlier the same earth was circle, that means I am making the square into a circle. Both that 179, that is, they'll meet on the opposite side, right? They're going to meet on the opposite side. So exactly 0 degrees ka opposite side kaun sa hai? It is 180 degrees. On the opposite side of the 0 degrees you will have 180 degrees, and we said that 180 degrees longitude is the one which is going to be our international date line. Okay? So let me show it to you on a 3-dimensional scale. Look here. See, if this is your prime meridian, then the opposite side, this is 180, we call this as international date line. And I've opened the earth. When I open the earth, this is what is the earth looks like, right? Now see, we calculated time and latitudes and we linked it with each other. How did we do it? Simple. Earth takes how much time to rotate a full circle? Earth takes this earth is taking 24 hours to rotate 360 degrees, right? Now for 1 hour is equal to how many degrees? Cross multiply 360 divided by 24, right, which is equal to 15 degrees. That means 1 hour is equal to 15 degrees, right? That means every 1 hour the earth has to rotate how many degrees? 15 degrees. Now likewise, let me go and calculate if 60 minutes is equal to 1 hour. If I'm in 60 minutes 15 degrees is we are able to move. Now 1 degree will move in how many minutes? In how many minutes will move 1 degree? You calculate and tell me. It is, if 1 degree 15 degrees will take 60 minutes to move, cover 15 degrees. So 1 degree will be covered in how many minutes? It is 4 minutes, right? 4 minutes is equal to 1 degree, right? Clear? That means if earth moved 1 degree, it is taking 4 minutes. If earth moves 180 degree, now you tell me, if earth is moving 180 degrees, how much time it takes? How much time it takes for the earth to move 180 degrees? It takes 1 degree is equal to 4 minutes. So 180 degree is equal to 180 into 4 minutes, which is almost equal to 12 hours. Right? Which is almost equal to 12 hours. Right? Clear? So this is how the time calculations are done. Now let's try to understand this. For example, you see, this is the international dateline. Now where do you find the international dateline? The international dateline is present in the Pacific Ocean, exactly opposite to the prime meridian. This is 0 degrees, is there on the opposite side. This is international dateline, which is irregular line, which is almost passing through the 180 degree line. Now this is the line which will decide what is the date and when should the day start and when should the day end. So the entire world global community has decided that chalo, let's go and take this line as the date line, and this is where the date begins and this is where the date ends, right? So let's try to understand this. So look here, what is the longitude? You tell me which longitude passes through India. Which longitude passes through India? What is the Indian Standard Time longitude? The Indian Standard Time longitude is 82.5. See, this is the Indian Standard Time, right? Now let me try to show you on a practical scale. Let's try to come here. Suppose this is your prime meridian, which is 0 degrees. And remember, those places east of the prime meridian, they are always ahead in time. And those places which are west of the prime meridian, they are always behind the time. They are behind the time. So let's imagine this is your sun. This is your sun, right? Earth rotates from east to west or west to east. Now look here, this is your eastern side and this is your western side. Earth always rotates from west to east. It rotates from west to east. It rotates like this, right? So if India is present here, who will see the sunrise first? Is India seeing the sunrise first or the UK seeing the first sunrise first? India will see the sunrise first, and later on UK will see the sunrise first. After UK, who is going to see the sunlight? After UK, the sunlight will be seen by the countries which are there, west, that is USA. Then after USA, other countries. But somewhere or the other, don't you think that we have to start our day, we have to end our day, we have to decide this is the day, this is the place where our day starts and this is the place where our day ends? Yes. Yes, so that's the reason why we have taken that international dateline. But let me tell you, before I teach you the concept of international dateline, the concept of time. Look here, This is the longitude of 82.5 degrees eastern longitude, right? And this 82.5 degrees eastern longitude is the Indian Standard Time longitude. Now, if suppose time is 12, here time is 12 AM. ठीक है? What is the time on India? Here at 0 degrees longitude, the time is 12 AM. What is the time at 82.5 degrees east? ठीक है, I'm talking about east. You'd calculate and tell me. You know that 1 degree is equal to 4 minutes and 15 degrees is equal to 60 minutes, right? So 82.5 degrees means how much time? If time is 12 AM here, what is the time at 82.5 degrees east? Right? Calculate and tell me. Now take 10 to 15, 20 seconds of your time and then tell me. You can also drop a message. This is my contact number. I'll be happy to address all your doubts. Yes. Now you tell me, calculate, put your pen and paper and try to tell me if the time is 12 AM, what is the time at 82.5 degrees? If 1 degree is equal to 4 minutes, 15 degrees equal to 60 minutes, 82.5 degrees is equal to how many minutes? In simple terms, this 82.5 degrees is equal to 5 hours and 30 minutes. That means we are 5 hours 30 minutes ahead of this time. If suppose here it is 12 AM, here time will be 5:30 AM. Right? We are ahead of that time. Right? Now you tell me, see, this is 0 degrees, this is 82.5. I hope you got this concept. Any doubts? Okay. Now let me ask you one more question. This is prime meridian, 0 degrees. This is 10 degrees east and this is 10 degrees west. So what is the time gap between 10 degrees east and 10 degrees west? What is the time gap? कितना टाइम गैप होगा between 10 degrees east and 10 degrees west point? Yes. Suppose let's say that this is 6 AM at 10 degrees east. So what is the time at 10 degrees west? Always those places east of the Greenwich meridian are ahead and those places which are west of the Greenwich meridian, they are behind. So here this is 0, this is 10 degrees east and this is 10 degrees west longitude. Suppose 1 degree is equal to 4 minutes. That means it is 40 minutes. Yes. And 10 degrees from 0 to 10 degrees west, it is 40 minutes. Suppose it is 6 AM. What is the time at 10 degrees west? You just need to minus 40 plus 40, that is 80. That means 1 hour 20 minutes this particular longitude is behind. If suppose this is 6 AM at 10 degrees east, now 6 AM minus 1 hour 20 minutes or 80 minutes is how much? Batao. 80 minutes is how much? Is it 4:40? Here the time is 4:40 AM. Okay. Now this is how the time are calculated, right? This is how the time is calculated. So if I am going backward and backward and backward, always those places which are west of the Greenwich meridian, they are always behind, right? So what we have decided is that at some or other place we should start our day and we should end our day. So it is decided that we will be taking the international dateline as the start of the day. Means, where should the day starts for the entire world? It is said that the day should be starting at the international dateline, and this is the international dateline. Okay? See, we said that this is going to be the international dateline, this particular place. And this international dateline is not a straight line. It is an irregular line. Why? Because we wanted to create a day, start a day. So this is international dateline, and those places which are present west of the international dateline are the place where the day is going to start. That means, suppose if today's date, let's say today is 20th. Okay? Today is 20th. See, here the day will be 20. The day will start 20th day, which is, let's imagine that is Monday. Imagine this is Monday. Your Monday will start from these places. That means the first sunrise will be seen by the Japanese and the islands which are east. It is always said that the sun rises in the Japan. It is just because it is the first country which is one among those countries which will see the sunrise first, right? So we said that let's start the time here, day here. If it is Monday, Monday will first start here, and let's call it as 20. So after some time the earth keeps on rotating, right? It is like this. Look here. Let's imagine that this is the international dateline, right? This particular line is the international dateline, and we have decided that our day should start here. Now this is Monday 20th. This place will see as it slowly starts to rotate. Now this will become Monday 20th. After some time the earth rotates. Now this is Monday 20th. That means these places on the longitude. Likewise, it is moving ahead. So here this particular place, Monday 20th. Right? Now who is going to see the day at which country is going to see the day very last? Okay. First the day started in Japan, on the places near to that international dateline, and slowly as the earth rotates, the earth will start to see, these places will start to see that 20th Monday. Okay. That means the last place to see the 20th Monday is none other than those places, if this is your international dateline, those places which are present east of the international dateline, that means these countries are the one which are going to see Monday 20th, right? As soon as the earth rotates little more, and then here you will see 21st. But what is the time here? It is still 20th. If this is your Monday, this is still Sunday. Do you agree? Now see, 20th, this place saw first 20th. Next, this place will see like that 21st, 21st, like that. 21st will be seen by a place at the end by this particular places, those places which are present east of the international dateline, right? So this is the reason why we have taken longitudes and latitudes. Okay. First, suppose you see here, if suppose this is 20th and Monday, what will be the day and date? You tell me. The day just started here. So what will be the day and date here? Here the day and date would be 19th, and this is Sunday. Okay. Let me put it in another way. This is international dateline. That means this is the place where the day starts and the earth slowly rotates. So all the places which are facing the sun, they are going to see the next day. So let's come back to international dateline, and I'll tell you that this is Wednesday and this is 23rd. let's call it as this is Wednesday and this is 6th date, right? Now what will be the day and date here? The day will be here, it will be Tuesday, and the date is still 5th, right? This is how the international date line works. It is all about our convenience, and this convenience is the one which we have taken to draw the length and breadth of the time calculations, right? I hope you're clear with this. Any doubts here? I know you'll have a lot of doubts, but as soon as you read the chapters and the literatures, you will get to understand things easily. So let me quickly read out the concept of Indian Standard Time. See here, for entire India, we only have one time, right? See, but still we face a lot of problems here. Now, what are these lot of problems? These lot of problems are, number one, what is the westernmost point of India? That is 68 degrees. What is the easternmost point of India? That is 97 degrees. Look, the time gap between these two is very high. It is near about 1 hour and 52 minutes. 97 minus 68. Tell me, what is 97 minus 68? How many degrees? You tell me. हाँ, इतना टाइम क्यों लग रहा है आपको? Just calculate and tell me. Yes. अरे 30 नहीं होता है यार. It is. Yes. Okay. So whatever the number it is, in simple terms, it is, there is a time gap of 1 hour 50 odd minutes, 50 plus minutes. ठीक है. Suppose if the sun rises here at 6 a.m. Let's imagine the sun, let's imagine usually in summers at what time the sun rises? The sun rises here at 6 a.m. Right? Now, at what time should it rise? There is a time gap of 29 degrees का time gap है. ठीक है. 1 degree is equal to 4 minutes. So 29 into 4. How much? Yes, 1 hour 56. This is the time gap. That means if at 6 a.m. if there is sun rising at Gujarat, the westernmost point, at what time you could think of that the sun has rised there? See, the sun rises in the northeast at the easternmost point of India at somewhere around 4 a.m. ठीक है, around 4 a.m. and 4 minutes. ठीक है, at 4 a.m. and 4 minutes the sun rises. Now imagine if such early is the rise of the sun, wouldn't it be difficult to calculate the day-to-day activities? Yes. Now imagine a student wakes up even before, a small kid is always woken up even before the sun rises, because there is also dawn, twilight, and other lights will be there. Imagine they have to go and run for the sports or do something. They even wake up at 3:30 in the morning. Now, we wanted, the entire India is having a single time zone. That means a student wakes up at 3:45 or 4 a.m. in the morning, and if he or she has to go at 8 a.m. to the school, wouldn't it be a difficult task, because they have to spend 4 to 5 hours even before they are going to the school, and the school is going to be till 4 p.m. By 4 p.m. it is already pitch dark. Now let's imagine that at 6 p.m. or the darkness kicks in. Now at 4 p.m. itself the darkness will kick in. So these are some of the challenges. That's why we have different time zones. But India has only one time zone, so there is a demand for Chai Bagan time zone here. There is a demand for Chai Bagan time zone, and this Chai Bagan time zone is being asked by the northeastern people. Now, did we give? We did not give. If we are not giving, why are we not giving? You can also let me know. Right? Now, do you think we have to give a Chai Bagan time zone to the northeastern states? This is a question from my side. You think on your side and come up with solutions. Now, come back like that. India is a very small country as compared to other geographical areas. But think of Russia. Russia is too big. So that's why what do they do is they create time zones. They have different time zones. India has only one time zone, right? Now, a small homework for you. Which other country along with India uses the same time as India standard time? Options are Sri Lanka, Bangladesh, Bhutan, Nepal, Pakistan. So my question is, which other country also uses the same standard time as India? It is Sri Lanka, Bangladesh, Bhutan, Nepal and Pakistan. You tell me the answer. You can also drop me a message as well. Okay. I hope you are clear with that. Now look here. Look at the international dateline concept. See, the international dateline concept is like this. Just a minute. Look at this image. This is your international dateline. Why did we draw irregular line? We draw this irregular line because we do not want to cut a particular area as one date and another date. So that's why we have chosen to skip few countries and draw this in an irregular manner. Now see, this is east of the international dateline and this is west of the international dateline. Okay, this is east of the international dateline and this is the west of the international dateline. You all know that day always starts at this particular place and then the day goes around and comes back, and this is the last place which will be witnessing that particular day, right? So you tell me, if I am moving from east to west, will I be gaining a day or losing a day? If I am going from east to west, will I be losing a day or gaining a day? See, here losing a day or gaining a day means, suppose in your life you only have 1000 days. If you add one more day, 1000 plus 1, that is called as gaining a day. Losing a day means instead of 1000 you will be only having 999 days. That is called as losing a day. Suppose the week starts like this: Sunday, Monday, Tuesday, Wednesday. Okay? If you are coming back to Tuesday from Wednesday again, that is called as gaining a day. Okay? Remember this. You are living in Wednesday, and if you can go back to Tuesday, that is called as gaining a day. So here, this is east and this is west. Imagine this is 21st of the month and the day here is Sunday. Okay? Here it is Sunday. If not Sunday, it is confusing to you, I'll make it as Wednesday. So if you are moving from east to west, did you gain a day or lose a day? See, here the day will be 20th and here it is Tuesday. In fact, you will lose that Tuesday. The distance between this particular place and this particular place, Alaska and Russia, is only 20 minutes travel by air. Okay? You have celebrated your birthday here, and or else you have celebrated your birthday here 21st, and you fly from here to the Alaska to Russia, or you go back to US or whatever it is, you just fly from this particular place to this particular place, then you can celebrate your birthday again. Likewise New Year. So it is always, if you are going from east to west, you will lose a day. If you are going from west to east, you will gain a day. Okay? Remember this. East to west, you will lose a day. West to east, you will gain a day. West to east means if it is 21st here, it is 20 here. You will go from here to here and you will celebrate your birthday again. If it is 21st, you will wait for the 21st and 21st will come here and you will celebrate your birthday. Like that. So this is the concept of eastern and western. If you are moving from west to east, add a day. If you are moving from east to west, you will lose a day. Right? So this is the time zone, and which is the country? It is Sri Lanka, which will use the same Indian standard time. Sri Lanka also uses whatever the time that we have. Sri Lanka also uses the same time, right? It is not Nepal, it is not Bhutan, it is Sri Lanka which uses the Indian standard time. Between India and Pakistan, there is a difference of half an hour, right? So this is what is the concept of international dateline. Now, the next concept that we need to learn here is the motions of the earth. Okay? It is motions of the earth. Look at this motions of the earth. Now motions of the earth, we'll be studying about rotation and revolution. Right? Rotation and revolution. Rotation means the earth goes around itself, it makes one full rotation. Now what is revolution? Revolution means if the earth is going around another celestial body such as sun, around the sun, how much time the earth takes to make one full revolution around the sun? It is 365 days. Right? That is called as revolution. Revolution will lead to the formation of seasons. Rotation will lead to the formation of day and night. Right? But to understand this concept, you also need to know fundamentally certain other concepts, that is area of illumination. Okay? You need to know the concept of area of illumination. See, you know that this is our earth, right? No matter what, earth will always have 50% of its area covered with sunlight and 50% of area it is in the darkness, right? So this earth, what does it do is, it goes around and it will take how many 365 days, or 365 plus 1/4 of a day, right? Now try to understand this. It will take months together to get its own seasons. So all these 365 days is divided into some months. You'll have summer, you'll have winter, but at which position there will be summer, at which position there will be winter, for that you need to have clear-cut clarity. So in order to understand that, you need to know the concept of area of illumination, the concept of axis. Firstly, try to understand what is the concept of axis, what is the concept of area of illumination. See, area of illumination means 50% of the earth is always covered with light. If suppose this is the darkness part of the earth and this is the side of the light, imagine your sun might be here, right? Sun rays will be falling directly on the equator or vertically. Sun rays will be coming and falling slantingly near to the poles, and they cover a large surface area, but these sun rays will cover small area. So that's why near to the equator or near to the Tropic of Cancer or Tropic of Capricorn, the sun rays, same amount of sun rays will cover small area. That's why the heat is more. But these sun rays which are moving towards the polar region, they cover larger surface area. That's the reason why you will have less heat here, right? Okay. First thing, you already learned what is called as area of illumination. Area of illumination is nothing but an area where the light is present, and non-area of illumination is nothing but where the darkness is present. I am telling you that 50% of the earth is always covered. Now see, let's imagine this is our earth. Okay? Look, this is our earth, and I am keeping the axis of the earth straight. This is the axis. Axis is nothing but the line on which the earth rotates. Imagine this is one earth. Okay? I also have an earth which is having tilted axis like this. Right? I have a tilted axis as well. So you tell me, if I am giving equal sunlight, imagine, look here, this is the area of the sunlight. This is the area of the sunlight and this is the area of the darkness. Had if our earth was in a straight line in this manner, then our earth, that is North Pole and South Pole, would have seen both sunlight at the same time and darkness at the same time. Look here, this is North Pole and this is South Pole. That means here you could have seen the equal amount of light at North Pole and South Pole, but in reality our earth is not straight, our earth is actually tilted. This tilt ki karan, you will get to know that if suppose I told you 50% of the earth is covered by the sunlight. Now see, if I have the sun here, let's imagine I'll keep the sun here, I'll also keep the sun here. 50% of the area will be having sunlight and 50% of the area will be having darkness. Now this green color area, let's imagine this is the darkness. Now look at, this is North Pole and this is South Pole. This is North Pole, this is South Pole. Now when the earth axis is tilted, you look and tell me, if this is the area of darkness, do you have sunlight on the South Pole? Do you have the sunlight? This is the area of the light. That means at the South Pole you have sunlight, but at North Pole you are not having sunlight. Arey yaar, how is this possible? Because our earth is tilted. Our earth's axis is tilted. And here, if the earth would have been in this manner, our earth would have faced equal amount of sunlight at every place. In reality, our earth is not like this. This is wrong. Our earth is like this. Okay? And this earth, what does it do is, it goes around the sun. Imagine, let me keep this here and let's imagine this is the sun. Now earth goes around the sun and then it comes back to its position in how many days? It takes 365 days. Sometimes the same earth might be here as well. Let's imagine our earth might be here, right? Let me take this orbit off so that it will become easy, right? Now look at this axis. See, if I am dividing the earth into two equal halves, try to understand this. See, be careful here, try to watch this. I am keeping the earth here and this is the earth. This is North Pole and this is South Pole. Now in this case, do you have sunlight over the North Pole? No, right? But exactly after 6 months, when the earth shifted its position to the next other point of the orbit, you will come across that this area, look here, only 50% of the area of the earth will have sunlight, that is the area of illumination, and this 50% of the area of the earth, you see, this is the area of the sunlight. Now you tell me, do you have light at the North Pole or darkness at the North Pole? Look here, this is the area of the darkness. Now South Pole, it is having darkness. That means South Pole is having darkness. In this case, North Pole is having darkness. Why is that? You might have heard that for 6 months you will have sunlight and 6 months you will have darkness at the North Pole and South Pole. It is because your axis of the earth is always parallel to its previous position. That means your earth is always rotating by keeping the axis tilted at 23.5 degrees. 23.5 degrees itself, it is like this. Look, earth came here to this position and from here it will come back. Now if suppose this is the position of December month, now this will be the position of June 21st and this is December 22nd. That means during the time of June 21st, your North Pole will have complete sunlight, and from there to here, see, until this position of the earth, this entire earth will go around and go to this particular position. Till then you will have complete sunlight. Okay? North Pole will have sunlight and South Pole will have darkness. You might be thinking of, see, if this earth is rotating, try to imagine, if this earth is rotating, your earth will rotate on what? Your earth will rotate on axis. Your earth will be rotating like this. Okay? Try to imagine, your earth is rotating on the axis. It is tilted and rotating. Irrespective of its rotation, rotation takes 24 hours, 1 day. Now look here, You rotate the earth on the axis. Do you see sunlight on the south pole? No. Axis pe rotate karo. Axis pe rotation means think this is the globe and the earth is tilted in the same way, and then start to rotate the earth at this place itself. The south pole will still experience darkness. So that's why you might be hearing that there are 6 months of darkness and 6 months of sunlight in the north pole, 6 months of darkness in the south pole, 6 months of sunlight in the south pole. All these things are because of this tilt in the earth's axis. Now come back and let's try to understand the positions of the sun, earth and the seasons. Look here. During the months of earth has very important positions. Now these positions are like this. Before that I wanted you to watch this particular video, which will have a better clarity on how the earth solstice or the positions of the earth will work. This is the equatorial plane of the earth, and this earth is facing the sun, right? But the earth is tilted, right? Your earth is not in a straight line, it is rather tilted. Look here, when the earth is tilted, only 50% of your earth, this particular area will have sunlight. That means south pole will be experiencing sunlight. North pole, no sunlight. Here, this is 50% of the area is having sunlight, right? Okay. The tilt is 23.5 degrees. Look at that. Darkness is there on what? Darkness is there on the half of the earth. Now the sun rays will be directly falling on one of those latitudes. Okay? But this sun which is there is always stationary there. Earth which keeps on rotating from one place to another place. Right? I hope you got this, and you need not understand this in a very detailed manner, so don't worry much. Okay? I hope you got the basics here. Now let's quickly go towards the positions of the earth. Okay? The positions, the day, night and the seasons. Look here. See, there is summer season, there is winter season, and there is also autumn season, there is also spring season. For all of this, for you to understand, you need to know the positions of the earth in a detailed manner. Let's try to understand this. Look, just a minute. I hope everyone knows the orbit of the earth. Look at this. If this is the sun, right? Now imagine the earth, this is 21st of December, okay? And this is 3rd of July, this is 21st of June. So during the time of 21st of December, you see the sun rays, look at this. If this is the Arctic Circle, this is, and this is Antarctic Circle, right? Antarctic Circle. And your sun rays which are there, they will be directly falling on what? They will be falling on, if this is your Tropic of Capricorn, okay? Your sun rays are directly falling on Tropic of Capricorn, okay? And this is your equator, and this is your Tropic of Cancer. So on 21st of December 21st, sun rays directly fall, they directly fall on Tropic of Capricorn. Next, 24 hours of day you can see at South Pole. 24 hours of darkness is at North Pole. And it is winter in the Northern Hemisphere, right? It is winter in the Northern Hemisphere. Now these are the basic facts, and this is what will be asked by UPSC. Likewise, you come exactly after 6 months, December 21st to June 21st or June 22nd. Look here, the sun rays will be directly falling on Tropic of, your sun rays will be directly falling on what? They will be falling directly on Tropic of Cancer, which is 23.5 degrees north. And your Arctic Circle, which is there, this is your Arctic Circle, it will have 24 hours of sunlight. That means this is your winter. This is your winter, right? And 24 hours of darkness in the southern hemisphere. This is 24 hours of darkness in the southern hemisphere, right? This 24 hours of darkness in the southern hemisphere, and we call this particular time period as summer, or this day as summer solstice, right? And we call this day as December 22nd as winter solstice. On one side you have summer solstice, on the other side you have winter solstice. Likewise, you look into the positions of the earth. The positions of the earth are like this. I'll step aside so that you can watch this particular slide. Look here. This is summer in the southern hemisphere, winter in the northern hemisphere. This is in the month of December. But come to June, you will find summer in the northern hemisphere, winter in the southern hemisphere, 24 hours of darkness in the southern hemisphere, 24 hours of light at the North Pole. This is not a southern hemisphere in the sense, it is near to the poles, right? So in totality, you will also have spring season and autumn season. These are the positions, right? And they are given different names. Now what are these different names? These different names are like this. If this is the sun and this is June 22nd, on 22nd June we will call it as summer solstice, and it is summer in the northern hemisphere and the tilt is towards the sun. That means the axial tilt, this tilt is towards the sun, and you go exactly 6 months away, December 26th, the tilt is this axial tilt which is there, it is away from the sun. This is away. That means the axial tilt is away from the sun. The North Pole axis which you take, it is always away from the sun. Yes, this is towards the sun. But when it comes to in the month of March 22nd, see, this March 22nd is called as equinox. Equinox, because equal length of day and night will be there at the North Pole and the South Pole as well. Even at your place, you will see 12 hours of sunlight and 12 hours of darkness, right? 12 hours of light and 12 hours of darkness you will see at any place on the earth on the day of March 22nd. Also, on 22nd of September, this is also called as an equinox, but this is autumnal equinox. This is vernal equinox. And on this equinox, on both the equinox, you will have equal length of day and night, right? UPSC will ask a question that at 21st or 22nd of September, 21st or 22nd of June, do you have 24 hours of darkness in the southern hemisphere? The answer is yes. Or else they will ask, the sun never sets beyond Arctic Circle. It is said that if this is Arctic Circle, this is sunlight, the sun never sets beyond the horizons of the Arctic Circle. Yes, on this day, if this is Arctic Circle, the entire Arctic Circle and above regions will have 24 hours of sunlight, right? So these kind of questions are asked by UPSC. Now here in a nutshell, regarding the rotation and revolution, when you look into the rotation and revolution will be, rotation will lead to day and night, and revolutions will lead to what? They will lead to seasons. That means there are 4 seasons, and all of these 4 seasons are also based on the positions of the earth, right? So let's quickly have a look here. The difference between solstice, one is June solstice, this is summer solstice, and this is winter solstice, that is December. Try to have a look. Now, do you have light? First, let's look into the December solstice. 24 hours of night at the North Pole, right? 24 hours of darkness at the 24 hours of darkness at the North Pole, right? 24 hours of darkness in the month of December. But exactly opposite can you see at the North Pole during the time of June solstice, summer solstice, 24 hours of dark, 24 hours of light, right? So this particular area, this is called as Arctic Circle, and this entire Arctic Circle is under the influence of light. Now this is Antarctic Circle, this entire Antarctic Circle is under the influence of darkness. This is the area of illumination, is always 50% of the earth. Dekho, 50% of light is there on the earth. It is just that our earth is tilted here. That's it. Because of this tilt, you get to see seasons. Now in the north, it is summer. And this is winter in the southern hemisphere during the months of June. But exactly, this is winter in the month of December, and this is summer, right? That means during the time of winter season in the northern hemisphere, it will be summer season in the southern hemisphere. Summer, if it is summer in the north, it is winter in the south. If it is winter in the north, it will be summer in the south, right? So this is how the rotation and revolution will impact the positions of the earth, right? Clear? Any doubts here? You can always drop a message to me. I'll be more than happy to address all your questions. Now this is the concepts of rotation and revolution. Now equinox, let me quickly read out the definitions of the equinox. On 21st of March and 23rd, direct rays of the sun fall on the equator. So that's why it is called as equinox. Equal length of day and equal length of night. As this position, neither of the poles are tilted towards the sun. Therefore, the whole earth experiences equal day and equal night. This is called an equinox. On 23rd of September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is the case on 21st of March, when it is spring in the northern hemisphere and autumn in the southern hemisphere, right? This is the content. Equinox ki conditions mein dekho, equal length of day and night. This is your equinox. North pole, south pole. That means you will see equal length of day and night. This is equator. 12 hours of day will be there, 12 hours of night will be there. On which days? In the month of September and in the month of March 21st and September 21st or 22nd. One day here and there, right? This is how you see the positions of the earth. Now finally, I'll conclude to show you the seasons, how they look. This is how they look. December, you have winter, and always geography is studied with respect to northern hemisphere. We don't consider what is happening in the northern hemisphere because the entire geography books are written by people in the northern hemisphere. So that's the reason why we consider northern hemisphere as the reference, right? Clear? So this is northern hemisphere and southern hemispheres. Winter, 21st of or 22nd September. Spring, March 20th. This is northern hemisphere. Summer, June 20th or 21st. Come to September, it is autumn in the northern hemisphere, September 21st or 22nd. That means the rotation and the revolution. Revolution will lead to seasons, rotation will lead to day and night. Are you clear with this? And one last thing that I wanted to tell you is, look at the positions of the axis. See, look at the positions of the axis. This is the position of the axis, right? And this is also the position of the axis. Are they parallel to each other? From the month of summer, that is June, to the month of March, the axis is parallel to each other. Now let me take this earth to the month of September or to the month of June. Now this line and this line, you go wherever it is, the earth will always have its axis parallel to the previous position. The axis of the earth is always parallel to the previous position. Okay? This is something which the examiner can ask you. the earth axis is parallel to its previous position. The examiner can ask you this, right? So this is what is you need to know about the rotation and revolution in a detailed manner, right? Clear? And one last thing, the concept of perigee and apogee. Okay, see, during the month of the June time period, the distance from the sun to during the month of June, the distance from the sun to the earth is far away. During the month of January, from the sun to the earth, the distance is less. It doesn't matter whether the distance from the sun and the earth is less or more. The seasons can vary. Suppose you should not think that if the earth is near to the sun, that is going to become a summer. No. During the times of the summer, the earth will be facing look at this. During the time of summer itself, the earth is far away. This is the month of July. In the month of July, the earth is sabse dur. Now this is called as apogee. Okay? And during the months of winter, the earth is nearby. This is called as perihelion. This is called as aphelion. Okay? Aphelion and perihelion. Apogee, I'm sorry. Apogee is the word which is used for moon. When the moon is apart from the sun, apart from the earth, it is called as apogee. When the moon is near to the earth, it is called as perigee. Right? Now perihelion means it is with respect to sun. Perihelion position is during the January. Right? And the aphelion position is during the months of, yes, apart is aphelion. It is during the months of summers, June and July. Right? Now, one question to you. So, on 21st of June, the sun rays falls vertically on. You can also drop a message to me. You already have my contact number, right? On 21st of June, the sun rays falls vertically on the Tropic of Cancer or Tropic of Capricorn, the equator, the Antarctic. See, the answer is the Tropic of Cancer, right? Look here, the apparent movement of the sun is overhead at the equator twice a year on, it is equinox. Equinox is on which months? It is in the month of March and September. March and September you will have equinox, right? Equinox is in the month of March and September. No, one is in the month of March, other is in the month of September. Now that's it. This is what you need to know with respect to the positions of the earth, and the origin and evolution of the topic is now considered to be complete. If you do have any doubts, I would be very happy to address all of your doubts. Thank you and stay connected. We'll meet in the next topic. In a very beautiful manner, I'll be explaining you the origin of the interior of the earth and the interiors of the earth layers. We'll see you in the next class.